Hello, everyone. So I did this as other because I didn't really know what to label it as. But we're just going to be going over some Algebra 1 concepts, and I really hope that this is picking up my voice. I'm going to go check this out real quick, and then I'm going to hop right back to it. Oh my goodness, I did not mean to. We're just going to make sure that my voice can be heard, that there is no technical difficulties, because I would absolutely hate it if there is. Okay. We have voice. We love that. You can hear me. It is a little bit echoey. That's just because I accidentally forgot headphones. I'm very sorry for that. But we're going to go over a couple Algebra 1 concepts, starting off with slope, actually. So a couple things that we were given is determining different slopes, whether it's a line, whether it's an equation, and then using those slopes to help us sketch a line out ourselves. Now, with this as well, something that we're going to look at is absolute value, and there's a little different trick for finding these absolute values and creating these lines themselves. But we're going to just start off with the basics, and that is determining the slope of the line using the points that are given. I'm probably going to do maybe just the odd problems. That way half are done, and then people can go and look at the other half themselves if they want to. So with determining the slope, what is slope? Slope is going to be the direction a line is going. And a lot of the times we represent that, well, most of the times, all the times, we represent it as rise over run. Now, what this rise means, it's how far a line goes up or down for your rise, and then run is going to be left and right. And that's going to be for all the different lines that you see. And that's why for slope 2, a lot of the times you see it as a fraction, because it's set up as rise over run. So looking at the odd problems here, we're just going to count by ones. And we also say that slope is represented by m. Now, honestly, off the top of my head, I don't know why they use the letter m for slope, but that's what we use. For these, unless we're told otherwise, we are just going to count by 1 units. 4, 5, 6, 7, 8. And then we have -1, -2, -3 if we go down, 1, 2, 3, 4 if we go up. Now we're going to be using the points that they're given. We're not going to be creating our own points here. So if we look at this line, the first point that we come across, we're just going to call this point A. No particular reason. I'm going to call it point A. And we're going to count how far to go to get to point B. Now, since we do rise over run, I am going to go up or down first. So from going to point A to point B, we would go up 1, 2, 3, 4 units. We went 4 units up. Up is going to be a positive direction, so I'm just going to write a positive 4. From there, we go to the right 1, 2 times. So right is a positive direction, so I'm going to write a positive 2. We will go ahead and simplify for this in order to get the final slope, but that's just stating that 4 over 2 would just be 2, or 2 over 1. This is what we say is the slope of the line. It would go up 2 into the right 1. And even if we followed that track, up 1, 2 to the right 1, we would still end up with a point on the line. That is how we determine the slope of the point of the line whenever we're given these points. And it even says reduce when possible. We typically do that even if we are told, or even if we aren't told to. So looking at number 3 as well, I like to start from left to right. So because of that reason, I'm going to say this point here is my first one. It's going to be point A. And this one's my second point, point B. And keep in mind, I just found this worksheet online, so I know that the points are a little off. I hate that the points are a little off, so we're just going to give our best guess. So from here, rise over run. We're going to go up 1, 2 units first. So I'm going to start off with the 2 in my top. From there, we are going to the right 1, 2, 3, 4 times. Now this one is a little bit different. This is a 2 over 4. This would reduce down to 1 over 2 or 1/2. Now depending on what teacher you have, you may want to reduce it down to 0.5. I like to keep mine as fractions, so I'm going to keep it as 1/2 because 2 over 4 does get reduced down to 1/2. Looking at our next odd problem, we have this number 5, but we're going to repeat the exact same pattern. I'm going to go up or down first from my first point, which I'm just going to label as A, to the second point, which I'm just going to label B. From A to B, you got to go up 1, 2, 3, 4, 5, 6, 7 units up. I go right 1, 2 units to the right. Now from here, it really just depends on your teacher. I would be okay with 7 over 2 simply because this just tells me I'm going to go up 7 units and to the right 2 units. Some may want you to reduce, whether it's as a decimal or as as a complete fraction, not complete. I can't even think of the name of it now. Some would just want to simplify. 2 goes into 7 3 times, leaving 1 left over. So 7 over 2 could just be 3.5, but I actually like the 7 over 2. That really just depends on your teacher. Now 1, 3, and 5, notice they have all been positive. We've all been going up and then to the right. Number 7, on the other hand, looks like we have a negative slope. So for this one, we would still solve it the exact same way we would. We would go either up or down. Starting at this point A and this point B, notice we are now just going down 1, 2 units. What I like to do whenever I'm going in a negative direction, I like to go ahead and write that it is a negative number. Down, we consider up to be positive and down to be negative. So I just go ahead and write it's a negative 2. I went down 2 units. I'm going to keep that in my top because that is signifying either I'm going up or my down. Now I am still going to go to the right. I go to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. So since I'm going to the right, right is a positive direction. So right is positive, making left a negative direction. But since I went right, I went positive 12. We can still simplify the slope. Negative 2 over 12 will reduce down to a negative 1 over 6. This just means that if we go down 1 and to the right 1, 2, 3, 4, 5, 6 units, we would still end up with a point on the line, which for this case we do. But since it gave us our 2 different points that we needed to use, we still have that same slope. It will still reduce down to a negative 1 over 6. But that negative just comes into account because I went down those units to start off with. I will actually go back and look at number 8 just to kind of explain to you what the slope would be and physically write out our rise over run. With this slope, notice we're not really given any 2 points. That's because this is a special kind of slope. Special slope. So if we look at it, we are not going left or right any, or not, we are going left or right. We're not going up or down, We're not going up or down any units. So this would actually be a slope of 0. We are constantly moving in a left or right direction, making the slope 0 units. You're going left or right. Now, say, for example, I'm going to do a new line here. If you're given something like the green line, this is another special slope, where instead you have an undefined slope. And that's because you're constantly going up or down and not going left or right any at all. So this would be the same as 0 over infinity for your red slope for this line here. Because since you're not going up or down, that would be 0, but you're constantly going left or right. So 0 over any number is still going to be 0, even if it's infinity. So we would just say this is a 0 slope, whereas the green one, it's undefined because we'd say it's infinity over 0 because you're not going left or right at all, and we don't put fractions over 0. That is what we call undefined. So those are special cases. Those are why they're the special cases for number 8. And I noticed that it doesn't have an undefined slope, so I went ahead and explained why it's undefined. Looking at number 9, still looking at slope based off the 2 points. I'm going to label this one A and this one B. I am going to go a little bit faster now. I'm still going to color code where I can, but just going a little bit faster. We're going up 1, 2, 3, 4 units, up 4. Ooh, sorry, I'm watching a dog and she just kind of scared me. And then I'm going to the right 1, 2, 3, 4 units. This one's a nice pretty slope of 4 over 4, which is 1. Last one, looking at lines. I'm going to label this bottom one A, top one B. This one kind of looks like a big slope here. M equals. We're going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9 units up. But then to the right, 1, 2, 3, 4, 5, 6, 7, 8 units. For this one, there isn't much to simplify for. I would even just leave it exactly like this. But in case your teacher does not like this, you could always just put it as 1 and 1/8. I personally like it. Improper fraction is what I was looking for earlier. I like to keep it as an improper fraction because this tells me you go up 9 and then to the right 8. But I know some teachers like to go ahead and simplify. This would simplify down to a 1 and 1/8 slope. All right, so the odd problems just for these examples. So the next thing we're going to look at is finding the slope of a line given an equation. Still looking at the odd problems. Now for these equations, we're going to be looking at slope-intercept form. So y equals mx plus b. Just like before, m will be used to represent our slope, but now we also have this b character. B is going to represent what's called your y-intercept, which is just where your line crosses your y-axis. That is all your B represents, is where your line crosses your y. Keep in mind, though, especially for this one, we aren't asked to find your y. We're asked to only find the slope. So as long as we have it in y equals mx plus b form, we are always looking at that number in front of your x, which we count that as being your m. And looking at number 1, what's kind of nice is that we don't have to solve for anything. It is already in y equals mx plus b form, meaning we are only looking at that number in front of x. From here, we would state that our slope is equal to a -2. That's all we'd have to do. We don't even have to solve. So that one's kind of really nice. Number 3, we have to solve a little bit, but nothing too drastic. We have to get y by itself. At this current moment, it's 7x plus y. Something I like to point out is that when solving for a variable, We do PEMDAS backwards. So your order of operations backwards. So instead, whenever we solve for a variable, we're still doing the opposite. So since I see addition here, a positive 7x, we will need to subtract a 7x on both sides. But we're going to start off with either addition or subtraction. And then we're going to do multiplication or division. Then we deal with our exponents. And then we would touch our parentheses last. When we solve for a variable, we do the opposite of the order of operations. We do the opposite of solving an equation. For this one, getting y by itself, though, it is a positive 7x plus y. To get rid of that 7x, you got to subtract it on both sides, meaning that this is going to turn into y equals a negative 5 minus 7x. Notice what we need, though. We need it in y equals mx plus b form. So that means we need to do a little bit of a switch. In order to switch it, you have to keep the signs together. A lot of people will change that into adding a negative number if you have subtraction, because addition is what you call commutative. You can switch your variables if you have addition. Switching it, that's just switching your position of these two terms, meaning it will be y equals a negative 7x plus a negative 5. And from here, a lot of people switch that plus and negative into just subtraction. I like to keep it. It's a personal preference, but whatever you're most comfortable with. Now we have it in slope-intercept form. We look at that number in front of the x, meaning our slope, our final answer, would be a negative 7. Number 5, we're starting to get into more difficult of problems to where we will have to look at this solving for a variable, looking at that PEMDAS backwards. We need to get y by itself. Now, the reason why I said we're going to have to do PEMDAS backwards is because we have 8x equals 9 minus 3y. We have to get rid of this 9 first, which is going to include subtracting a 9 on each side of my equation. What happens is that I get an 8x minus 9. So my minus 9, I just slip right past or beside my 8x equals. This 9 minus 9 will cancel, leaving me with just a negative 3y. So notice we did subtraction first before anything else. After we do that subtraction, we still got to get y by itself. It's negative 3 times a y. The opposite of multiplication will be division. So we will be dividing each term by a negative 3. So we got a couple things happening. This is going to be a 8 over negative 3x minus 9 over negative 3 equals, notice what's happening here, a negative 3 divided by a negative 3. Well, negative 3 divided by a negative 3, that's just 1. These will cancel, leaving you with just the y. I am going to rewrite this and simplify where I need to. I'm going to put my y first because I like it in my y equals mx plus b form. After I get y by itself, then I need to start simplifying and finding that slope. I need to find that slope since that's what I'm told to do. That's my instructions. So in finding this slope, I have an 8 over negative 3. We go back to this part of the equation and start simplifying my problems. So with this, 8 over negative 3. Well, this can be simplified, really not even simplified. I can just stick that negative, don't switch it. I can just stick that negative out in front, keep my numerator as is, and put my denominator as a 3. From here, we're going to put it times x, and that would be my first initial part of the equation. Now, believe it or not, that would be my slope, but for the sake of simplifying, I'm going to go ahead and solve the rest of the equation as well. Now, I have a negative. I have a negative because 9 over 3 will simplify to a 3, but having minus a negative will turn into plus a positive. So really my final equation, because it's always good to go ahead and simplify, would be a negative 8 over 3x plus 3. Pulling out your slope would be that negative 8 over 3. Depending on the teacher you have, they may be okay if you leave it at this. If they aren't, though, 3 goes into 8 twice, leaving 2. So whichever way they want to compute the slope, I like to keep it as an improper fraction, but each teacher is different. Last but not least, our last odd problem, we have 9x minus y equals 5. This one we are going, two more. We got 2 more, sorry. Going a little bit faster, I'm going to start off by subtracting a 9x on both sides to give me a negative y equals 5 minus 9x. Now, before I do anything else, I'm going to make this minus a negative and switch my 2 terms. Because keep in mind, addition is commutative, meaning that I'm able to go ahead and switch them after I make it addition. So this can actually be a negative y equals negative 9x plus a 5, because this is a positive 5. After this, I need to get rid of this negative sign. 2 ways to do it. I like to just multiply each variable by a negative 1. So from here, negative 1 times a negative y is going to be a positive y equals negative 1 times negative 9. Well, that's a positive 9x. Negative 1 times a positive 5. Well, that's going to be a negative 5. This one, we're pulling out that slope. That slope would just be a positive 9. Last but not least, this one's the last but not least. We have number 9. This one, all we have to do is a single thing. We need to multiply a negative 1 to each of your terms. So notice it's not just one number. You are multiplying to each of the terms. So that makes negative 1 times a negative y into our positive y, which is what we needed. We have a negative 1 times a negative 3x, which is a positive 3x. And a negative 1 times our 4 is a negative 4. Just pulling out the slope, since that's the only thing we need, our slope would then equal a 3. So it is the same thing every single time. It is the same process. We are solving for the variable. Or not even solving for the variable. We're solving for y and then pulling out the slope based on the equation that I am given. All right, so these are the examples. These are the even problems. I am going to save the video and post it on YouTube as well for those that need additional practice. So just keep that in mind. If you want to write some down, that is perfectly fine. But this is just extra practice. Which now we're going into sketching. So now we're going to be taking our slope and the x-intercept. We're going to be taking that slope and the x-intercept. Keep in mind as well that the slope is still just what is in front of your x. So with this equation, we now are taking into account the number in the very back. This, at least for the first one, I will be doing the odds too. B would equal a negative 2, meaning we are going to start at the point 0, negative 2. This is that y y-intercept. The y-intercept really is just kind of our starting point. It gives us a good place to start where we have a 0, -2. That means we go left or right 0 units and just go down 2. So I'm going to put a big fat dot on this -2, my starting point. Now past that, I have a slope of 1/5 for number 1. So my slope, m equals 1/5. What this tells me to do, it tells me to go up 1 and to the right 5 units. Now, a lot of people are just okay as long as you're able to tell what your slope is. I like to give 3 points to my line no matter what. So what we do for the first slope, I'm going to go ahead and put that 1 point up. We go up 1 and to the right 1, 2, 3, 4, 5. So my next point is going to be at this -1, 5. Something that we could do though too is go the opposite direction in both to give a nice solid line and just have 3 points. So if we went up 1, we can also go down 1. And vice versa, if we went to the right 5 units, we can also go to the left 5 units. So notice we're going in the opposite direction for the other point. Notice what this does to the slope. This would mean -1 would be down 1. To the left would be -5. This still comes out to be our slope as a +1 over +5 because a negative over a negative will still give us a positive value. This just gives you 1 more point to go off of. So I'm going to go down 1 and to the left 1, 2, 3, 4, 5 units, meaning that this third and final point that I could draw is right there. This is going to give you a nice line going through each of the 3 points. Now we're going to continue this pattern for each of your units. So I'm going to take a second. I'm going to make sure we have number 1 down, and then I'm going to scroll down to number 3 because it looks like it's starting to get a little bit more complicated. We're now having a +4. We have negative slopes. So we're going to take it step by step. I had to go check in. My dinner's being cooked, so I only got these couple of examples left, and then I get to go eat. Alrighty, and y'all, please feel free to let me know if you can't hear me. Please let me know if I'm too loud. Please let me know if there's any distractions. I'd rather you guys let me know if something's wrong or if you can't hear me, or if I'm being a little bit too loud. Especially on my live to where I can comment and let you guys know any questions. Perfect. I see you. Thank you so much for joining. Thank you so much for stopping in. I really do appreciate it. So with this number 3, once again, we're going to start off with our y-intercept. So what this means, this here, that just means your y-intercept, your b is a +4. This goes with the point 0, 4, which is that y-intercept. I'm going to start off by drawing that point first. This just means I go left or right 0 and go up 4 units. And I'm going to make that point big so I really know where we are starting at. After that, I'm now going to mess with that slope. That slope is a -7/3. So notice what this means. This means I'm going to go down 7 units and to the right 3 units. So I'm going to start off with my first point because some people are okay with 2. And then just for kind of a bonus, I'm going to, I really can't go up from my point. So I'm just going to go down 7 and right 3 because if I try to go up 7, I'm going to be way off my graph. So with this, down 7, 1, 2, 3, 4, 5, 6, 7. So I'm now at this -3, and I'm going to the right 3 units, 1, 2, and 3. So I'm at this point, make this kind of big too so we can really see it, of +3. positive 3, comma, negative 3. Because keep in mind your points are always in x, comma, y form. X is going to be your horizontal and your y is your vertical axis. So if you're asked about what points to use, you can always write down the points. And see this one, your y-intercept, we put that in yellow, is that 0, comma, 4. From here, since I can't really go up and left because it's a little far, I am just going to create my line that, hopefully it's straighter. There we go. Going through those 2 points. Now, if it was on paper, I would be able to use a ruler, but for the sake of doing it on the iPad, this is what I got. But that's what we do. We're going to pull out each of the points. So looking at number 5, starting with that y first, this just means that I'm starting at the point -1 or 0, comma, -1. So down 1 unit. It's a big fat red dot at that 0, comma, -1. Now my slope is that's my pin. My slope would be a -5, comma, 2. That just means I'm going down 5 into the right 2. Now I have a little bit of a problem here though. If I go down 5, I am off the graph. So another thing that I could do, I could go ahead and just do the opposite direction of both. So rather than going down 5, I could go up 5. And rather than going right 2, I could go left 2. This would give me the exact same slope. This would just be m equals +5 over -2, which is the exact same thing as a -5 over +2. So that's what I'm going to do. So I'm staying on the graph. I'm going to go up 1, 2, 3, 4, 5 units, and to the left 1, 2. This one I'm just going to do 2 dots because if I did a third one, I would be off the graph. Draw that straight line. And we put these arrows because these lines are going to go on forever. Unless we're told there's a stopping point, we put the arrows because these lines go forever. So that's why I put those arrows there in each of my graphs. Last one for this one, starting off with that y-intercept. We have b equals a 3, meaning my first point I'm going to use is a 0, comma 3, right there. After that, I have my slope. My slope is the number in front of x. My slope is a 1 over 2, meaning I go up 1 and right 2. And the reason being is because they're both positive directions. Up is positive and right is positive. So I go up 1 to the right 1, 2, making that other point here at 4. Nope, not 4. 2, comma 4, because we go right to 2 and then we go up to 4. Now for this one, I am going to put a third point simply because I have the space to. So doing the opposite of each of those directions, you go down 1 and to the left 2. Keep in mind that just is a -1 over a -2. Which still gives me a positive 1 over 2. So it still counts to the same exact slope. It's just a different way of writing it. Down 1, left 1, 2, creating this point here. This would be a -2, comma positive 2. Drawing a line that goes through all 3 points. Creating my arrows. That way it says that this line goes on forever and ever. And that's how you use an equation in order to create your lines. Now, if you need to, you could solve for y equals mx plus b first and then create your line. That could be a possibility. Solve for y equals mx plus b first, and then create your line. But you will always need to have it in your y equals mx plus b equation first. You will always need to have it as that first. All right, last but not least, absolute value. This one's the only main different one. This one's where it is truly best that you just plug in x values and solve for each. Now, what do I mean by that? That means this is going to be, we're going to have a chart. Oh, there we go. We're going to have this chart. We're going to have an x values, and then we're going to have y equals your, it's called a function or your equation values. If you are not told any differently, go ahead and stick with some of the easiest numbers that you have. The easiest numbers that we typically stick with, as math teachers at least, is -2 to +2. So what you do, you are going to take your equation, which I'm genuinely just going to copy and paste these equations for each one. We're not going to do anything super serious. So you really take each of these equations and copy and paste it. I'm moving my entire worksheet now. We're going to paste, because after we copy and paste, we are going to solve. So I'm going to see if I can just copy all of this, make it a little bit faster. Yep, perfect. I keep on moving my worksheet here. Sorry, it keeps on moving around. I don't mean to. Technology is not always my friend. Maybe I'll just write it to kind of, yeah, I'm just going to write the last one since I'm not going to fight with it anymore. Absolute value, x plus 1. But the point is, it's going to be the same equation no matter what. The only difference is that we are going to erase this x and replace the x values we're given off to the side. So if I see a -2 to start off, I'm going to start off by plugging in a -2 and then solving. If I see this -1, I'm going to plug in a -1. If I see a 0, I'm going to plug in a 0. If I see a 1, I'm going to plug in a 1. And if I see a 2, I'm going to plug in a 2. And then go through the process of solving. What this is going to do, it is going to give me each of the values for my equation. And I almost kind of wish this second half of the problems were cut off. So I'm going to flash this for a second just so people can copy it if they want to take a screenshot or copy the questions on their own. But I am going to edit this paper just so I have a little bit more room on my end. So cropping, that way I can show my work a little bit more, a couple more seconds in case people want a screenshot just so they have other examples. Okay, so I did this so I can show my work. If I have, I'm going to start off with the yellow. If I have an x value being a -2, what this allows me to say, the absolute value, first of all, the absolute value, if you have the absolute value symbol, you are going to make the value positive. Notice it's not opposite. Notice it's not negative. What absolute value represents is distance, and distance is always positive. You can even kind of think about it as a car. In a car, you are always going to drive, even if you drive backwards, your odometer will always go forward. There's a purpose for that. It's because distance is always counted as positive. So since distance is always counted positive, your absolute value will always be a positive number. So just going through the process of solving, you're going to have your absolute value, -2 plus 1 is a -1. But the absolute value of a -1 will come out to be a positive 1. So what does this mean for our first point? This just means our first point, our x value was a -2, and the y value was a +1. This is the first point we're putting on the graph, is a -2, which means go to the left 2 and up 1. That is your first point for your graph. I am going to color code these first couple of ones until we get the hang of this though, but that's where my first point's going to be. Past that, we're going to keep on going. I got a -1 plus 1 because we're just going to simplify inside your absolute value first. That's going to be a 0. And the absolute value of 0 is just 0. This point or your next point would be a -1, comma, 0. So going to the left 1 unit, going up or down none. Next point I have is a 0 plus 1, which is the absolute value of 1. Well, this is just 1. Making the point 0, comma, +1. We have plugging in a 1, the absolute value of 1 plus 1. That's the absolute value of 2, which is a +2. Creating the point 1, comma, 2. And last but not least, I have plugging in this 2. This is the absolute value of 3, which equals a 3, creating the point 2, comma, 3. Now, something with your absolute value will always be in this V shape. Kind of the hint I like to give my kids is that if you see absolute value, it will always be in a V shape. That is what we're looking for. This one, we are in a V shape. We go down, and then we go right back up through these set of points. We would still do the arrows because our lines don't stop. Our lines will continue to go up in both of these directions. But after solving for the points, this is the graph that we got. Now that does bring us to number 3. We are going to repeat these steps no matter what. So looking at this next problem, I'm still going to color code just to kind of help us out a little bit. Our x values, we're not going to change our x values unless we absolutely have to. We might add a couple of x values to our problem, but unless we need to change our x values, we will always stick with our -2, which I'll color code. We'll always stick with a -2, -1, 0, 1, and 2. So from here, we're just going to plug that in. Y equals the absolute value of -2 plus 1 plus 3. Now, I am going to go through the process of solving just to kind of speed things up a little bit. This is where the order of operations would come into play. Do what's in your absolute value first. This would be the absolute value of a -2 plus 1, which is a -1. Keep that plus 3 on the outside. The absolute value of a -1 is a +1 plus a 3, which would give me a 4. This gives the point of -2, comma 4. You would take the x value that we were given at the beginning, and that would be the x for the point. And then what we solve for would be the y. So this first point that we have is a -2, +4. From here, next one that we have, y equals absolute value, -1 plus 1 plus 3 equals. Well, -1 plus 1, that's a 0, plus 3. This one's nice and easy. The absolute value of 0 is just 0, plus 3 is just 3. For some of these, especially if we don't have any multiplication, we start to see a pattern, because now my next point is going to be this, not 0, -1, comma 3. We start to see this pattern for our points. So next thing, we got this 0, plugging that in, 0 plus 1 plus 3. Well, 0 plus 1 is just a +1. Absolute value of +1 is still just 1. 1 plus 3 is going to be a 4. making this next point 0, 4, which means 0, go back up to 4. Now from here as well, notice we went down to our vertex. That's what we call this point here. The middle point is going to be that vertex. The middle point here, that was our vertex, which for the number 1 looked to be a -1, 0. For this one, it is a little bit different. This is a -1, 3. Depending on where you are on Algebra 1, you could find that based on the equation that you're given. But for the sake of not knowing where people are in their algebra courses, we're just going to solve it based on the equation, where it's that point, that middle point that comes down and then goes right back up. That's going to be our vertex. Solving for the blue, and then we'll actually be off the graph. So I'm not going to do that too. We have absolute value of 1 plus 1 plus 3. That's the absolute value of 2 plus 3. Well, that's going to be 2 plus 3, which is going to be a 5. Making this point a 1, 5. That creates this graph here. Make sure you have your arrows because these will go on forever and ever. They do not stop, but that would be the proper graph. Now, number 5 is kind of cool. And the reason why number 5 is kind of cool is because we have this negative sign here. Look at what this graph does. Still going to have my x's, y equals the equation I'm given, plus 1. And for the sake of being consistent, we're still going to use a -2, -1, 0, 1, and 2. Starting off with this -2, y equals a negative on the outside, -2 plus 1. Still do your absolute value first. Keep this negative on the outside. We have to. It's on your outside, so we're going to keep it on the outside. Only change what's on the inside of your absolute value. The absolute value of a -2 is a +2 plus 1. So notice what this negative on the outside is doing. It is changing the number back to a negative, and it does something to the graph too, which we're going to see. -2 plus 1 would then just be a -1, making our very first point a -2, -1. -2 means go left 2, down -1. Do the exact same thing for the next point. Y equals a negative, absolute value of -1 plus 1 equals. This is a negative, you keep the negative, but the absolute value of a -1 is a +1 plus 1 equals. Well, -1 plus 1 is a 0. So this point is a -1, 0, which is right there. Y equals, same ordeal, 0 plus 1 equals. Well, -0 is just going to be 0, nothing fancy. -0 is just a 0. 0 plus 1 is a +1. That makes the point 0, 1, which is right there. Keep on going. I haven't hit a vertex yet, and that's just because it hasn't gone in any other direction besides up, so I'm just going to keep going. Negative, absolute value of 1 plus 1 equals -1, because the absolute value of a +1 is still positive, but that negative on the outside turns it back negative. Plus 1, well, that equals 0. There we go. Now I have going back down. And I'm going to go ahead, if you wanted to go ahead and solve, that just would make that point right there. So notice what now is happening. I now have a downward graph because of the negative on the outside. Notice where my vertex is. I now went up to a point, and then at this point, I went down. So this point would still be my vertex. My vertex would be at this point 0, 1, because that's the point where even though I went up, I then went straight back down. So my vertex would be at a 0, 1. And I'm so glad that this is the last question because I'm not going to lie, my stomach just growled. I am ready for dinner. This one, I'm going to do relatively quickly. X, y equals a negative absolute value of x minus 3 plus 4. This one gets kind of high. So I'm going to start off with this negative 2. Pay attention, you have a negative on the outside. With this negative on the outside, that just means that my v is going to be shaped downward. I'm going to be going in the downward direction, and that's all because of the negative on the outside. Negative, plug in that negative 2, minus 3 plus 4. You will have to pay attention. Minus 2 or negative 2 minus 3 is a negative 5. Absolute value of negative 5 plus 4. Well, absolute value of negative 5 is a positive 5, but you still have that negative on your outside. That still stays there all the way to the negative or all the way to the end. So negative 5 plus 4, well, that's going to be a negative 1. Your first point would then be negative 2, comma, negative 1. Negative 2, negative 1. From there, negative 1, y equals. From here, you are just plugging it in and then solving. So I am going to do this relatively quickly. I'm still going to show all my work, but I'm not going to state every single step. Making this point a negative 1, comma, 0. Negative 1, 0. It's going to be a negative absolute value of negative 3, which that's a positive 1, making this 0, comma, 1. And you kind of get used to seeing a pattern eventually. Yeah, this one's going to go on for a little bit, but I'll show you what to do in case you don't have a vertex yet. Now, I don't know off the top of my head if this is going to show the vertex, but I will show you what to do if it doesn't. Creating that point 1, comma 2. Okay, so notice what's happening. What looks like have a straight line. What you need to remember is due to the absolute value symbols, we have to have a V. So don't automatically assume just because you've plotted all these points that you don't have or that you have a new shape. Just try some more variables. So now I'm going to try out a 3. 3 equals, and then just do exactly what we have been until I get a V shape. You have to have a V shape for these graphs. You have to for absolute value. It will not be any other shape but a V. So just try out a couple different points. Like now I'm going to try out a 4. I still don't have a V shape, so I'm just trying out another point. Y equals a negative absolute value of 4 minus 3 plus 4. 4, 3, which now, looky here, 4, 3, I now shot down back to my V shape. Or I'm starting now going back down the line. Meaning, and I'm not going to solve for this one, my next point would be a 5, 2 if I were to plug it in. So now I have that V shape. So what this allows me to say, I have my vertex, which you're supposed to with a absolute value of 3, 4, and this is what your V shape is going to look like. Is something along those lines. But you have to show it's a V. Absolute value will always have V-shaped graphs. That is a rule for absolute value. And just because if you plug in some numbers, just try out some more. Just try out some other numbers. Now, there are different rules. You could go ahead and pull out a vertex, but for the sake of not knowing what your teachers have taught you and what they haven't taught you, I'm not going to go through that process as a whole new lesson and a whole new different characteristics. But for the sake of just doing some practice, you just got to try out some other points. So, but that's it. I did the odd problems. Once again, I am going to save this video and post it onto YouTube for those that want to go and check some work and try some of the other problems out. But I hope you guys enjoyed. If you have any questions, by all means, please just send me a message and I'm more than happy to help you out. Thank you.